Hello everyone, welcome back to the fifth video in the series where we're making Meteor Galaxy. Thank you so much for sticking through the fifth video. I really appreciate that since it shows the commitment you're putting into learning this material. In this video, we're going to have the spaceship move around on the screen with rotation, so it'll be able to move in the direction it's facing. It'll also have some velocity. This will require you to know a little bit of trigonometry, but don't worry if you're brand new because I'm going to be explaining these concepts to you in this video. And don't be worried about the difficulty either, since we're only going to be working with right triangles and using sine and cosine. This is pretty much the simplest trigonometry you'll learn, and I'll explain it as best I can. So let's get right into it. Before we write the code for moving the spaceship, let's look at how that's going to happen. So when we have the left or right arrow keys pressed, that's going to rotate the spaceship. And when we have the forwards and backwards arrow keys pressed, that's going to move it along the direction the spaceship is facing. So what that will look like is if here's our spaceship right here, let's say it's going to travel at a 20-degree angle. So this is a 20-degree angle. And then we know it's going to have some distance right here to move. So maybe this frame, it's moving 4 units that way. Let's look at how we'd move that. So what we need to do is move it in the X and Y direction to put it in this upper right corner. And you can see if we draw a line right here, we're working with a right triangle. So this square right here just shows that this is a 90-degree angle. And what we can now do is use trigonometry to find the other sides that we need the ship to travel. So we'll find how far it needs to go in the X axis and how far it needs to go on the Y axis. So now I'm going to explain how trigonometry works. If you are really familiar with trig and this is no new concept to you, you can skip ahead to where I'm actually applying it to the spaceship movement. But if you're new at this, don't be afraid because I'll explain it the best I can, and the cool thing is you'll get to actually apply it right away. So it's not just going to be something you wonder, how am I going to use this? You're going to actually see how this works. So even maybe math isn't your favorite thing, but I hope maybe that you can learn something cool and really see the neat things you can do with it because of the application. So for now, I'm going to move this problem off to the side, and we're going to look at this in just a second. Next, I'm going to explain two functions that you can use to find use angles to find the length of sides, and those are sine, so this is the abbreviation for sine, and cosine. So the sine of an angle, so this is just representing an angle, is the opposite side over the hypotenuse. And the cosine of an angle is the adjacent side over the hypotenuse. So it's the ratio of the adjacent side to the hypotenuse. So when you take the sine or cosine of an angle, it's going to give you a ratio that corresponds to the sides of that triangle. And I'll show you what that means. Let's just draw a simple triangle over here and label the sides. So I'm going to have an angle right here, maybe let's say a 30-degree angle, and this is going to be the angle that we're going to look at. So all the sides will be labeled in respect to that 30-degree angle. So first, let's label the hypotenuse. The hypotenuse on the right triangle is always the side across from the right angle. So right here is the right angle. So this is the hypotenuse. And the hypotenuse is always the hypotenuse. It'll never be the opposite or the adjacent side, even if it looks like it could be. The hypotenuse is always the hypotenuse. So keep that in mind. I'll show you what that means in just a second. So next, let's label the opposite side. So since we're looking at the 30-degree angle, the opposite side is going to be this side because it's opposite from the 30-degree angle. So I'm going to label that with an O. And the adjacent side is the side next to the 30-degree angle that's not the hypotenuse. So it looks like right here, the hypotenuse looks like it could be adjacent to the 30-degree angle, but this is not considered the adjacent side. This side is the adjacent side because the hypotenuse is always the hypotenuse. So remember that. So now this might make the trig functions make a little bit more sense to you. So if you see right here, the angle we're looking at is 30. So the sine of 30 would be the opposite side, the ratio of this opposite side to the hypotenuse. So let's look at this triangle over here and try to solve for x. Since we have this 20-degree angle, we can, and we have this side that's 4, we can use that to find this side, x, how far we have to travel the x-axis. So let's label these sides. X, or this side right here, would be the hypotenuse. So the 4 is the measure of the hypotenuse, and x, this distance right here, would be the adjacent side. So right here, we have the hypotenuse and the adjacent and the 20-degree angle. So from these things, we can determine what trig function we need to use. So you can see cosine deals with the adjacent side and the hypotenuse, and we know the hypotenuse, and we know this angle. So there's only one unknown, which is the adjacent side, so we can use that. So let's take a look. I'm going to change the color for the math. So first, we're going to use the cosine of the 20-degree angle is, so the adjacent side, so that's going to be x, so we'll put the variable here, over the hypotenuse, when the hypotenuse is 4. So next, what we need to do is multiply both sides by 4, because we're going to isolate x. So do that. And so x would equal 4 times the cosine of 20. So from here, you just plug that into a calculator. So if I plug that into the calculator, I get about 3.8. So that's how far it would need to move on the x-axis. The next thing we want to do is develop a formula so that the code can solve for the x and how far we need to move in the x and y axis if we give it an angle and a distance to travel. All right, so now let's look at just a generic triangle that we'll use to model traveling at an angle. So here I'm going to draw triangle, and I'm not going to give a specific angle, I'm just going to give a variable. So for that, I'm going to say A. That's going to be the angle that the ship is traveling at. So we could put the spaceship right here. And then D is going to be the distance that the spaceship travels. And from that, we're going to calculate how far it needs to move on the x-axis and how far it needs to move on the y-axis. Next, let's label the sides of the triangle in respect to angle A. So first, let's label the hypotenuse, which is going to be this side across from the 90-degree angle, so the longest side of the triangle. And then the opposite side will be the distance that will travel on the y-axis, and that leaves the distance it'll travel on the x-axis, be the adjacent side. And I'll just label it ADJ so it's not going to be confused with A. All right, next let's write some formulas. So first, let's solve for the y-axis. So if we look at the y-axis, it deals with the opposite side, and right here, this function sine deals with the opposite and the hypotenuse. The hypotenuse is what we're going to know. So if we were to have like parameters for a function, it would be we'd give it the distance and the angle. So right here, these two are going to be known, and then the x and the distance we'll travel on the x and the y-axis are going to be unknown. So we're going to be solving for x and solving for y. So if we solve for y, we'll pick sine since that deals with the opposite side. So we're going to say the sine of A is going to be equal to the opposite side, so that'd be y, over the hypotenuse, so that'd be d. Now we can isolate y by multiplying both sides by d. And so y would equal d times the sine of A. So you can see we just made this little formula for how we can calculate how far to move on the y-axis. Now let's do the same for x. So I'm just going to delete this, and we'll put the completed formulas at the top. Now let's solve for the x-axis. So if we look at the x, how far we need to travel on the x-axis, that's going to be the adjacent side. And cosine deals with adjacent over the hypotenuse. So if we do cosine of A, that would equal the adjacent side. So that'd be x over the hypotenuse, which is d. So we can solve for x the same way we solve for y by multiplying d on both sides of the equation. So that's the distance. Cancel here. And then d times the cosine of A equals, or I'll put the equal sign on the side, x equals d times the cosine of A. So now we have our second formula. So I'll put that right here. So with these two formulas, we can solve for how far we need to travel on the x-axis and the y-axis. And now, for some of you, this might have been your first lesson on trig, so congratulations on learning a bit about this. And if it's still a little bit confusing, it's all right. Like if this is the first time you've heard of it, I don't expect you to understand it perfectly, but just try to understand it as best you can. And of course, there are online resources that you can use to review it. There's one last thing that I just want to show you, just so that you can be aware of it, because you'll learn it later in math class. And that's a third function, trig function called tangent. And that, I'll show you that. So tangent gets abbreviated TAN, and the tangent of an angle is the opposite side over the adjacent. So if you were to know like what the this side is on a triangle, or here if we have the opposite side and the adjacent, if you knew the opposite side and you wanted to know the adjacent, and you also knew like an angle here, so like angle x, you could use tangent to solve for the adjacent side. So that's a third function just to be aware of, but we aren't going to use that in this video. Now in the code editor, let's take the formulas that we wrote and turn them into functions, just so that it's easy to remember how we did the math. So I'm going to put these just kind of at the bottom, since they're just little helper functions. And the first one that we'll write is function get move x. So this will get the distance that we need to move in the x direction, and it's going to be based on an angle and a distance. So angle will be the angle of the object. So right now we're going to do the ship, but later we'll have other things like laser beams and meteors. And then distance is how far it's going to travel at that angle, and it'll return how far it needs to move in the x-axis. So I can just write a return statement, and we can just do the math right here. We're going to do distance times, and then for x, it's the cosine, and it should be math.cosine to access the cosine function of the math class. So math.cosine of angle. And then for get move y, it's going to also take in an angle and a distance. And it's also going to return distance, and then times math, but this time the sine of the angle. So these are the same formulas that we wrote. earlier, now they're just put into a code form. So now the computer knows how to calculate how far it needs to move in the x and y axis using trig. When we're flying the spaceship around, we don't want it to just start and then stop instantly. What we want it to do is drift around a little bit. And so the next thing I'm going to show you is how to set up some basic physics or physics simulation. So these won't be perfect, but they'll allow you to simulate physics in a way that makes sense for your game. So let's look at the scenario. If we have the spaceship right here and it's going to move in the direction it's facing. Let's say we have two variables. So there's going to be a velocity, and then there's also going to be the position. So right now we're just going to say it's a single axis. It's going to move along this way. So just velocity and position. So position would be 0 here, and it increase as we go this way. So what we can do to make it move, like accelerate when you press down, we can add to the velocity. So for every time, let's say the up arrow key is pressed, that's the up arrow key, whenever that's pressed, we're going to add a speed to the velocity. So let's say we're going to add 2. And then we're to the position, we're going to add the velocity to the position, and the position is just where it is. So let's say this gets run once, it's going to move 2, because we've pressed down the up arrow key, and then 2 gets added to its position. But because our velocity increases, so this would be in code like plus equals, the next time we run it, velocity is going to equal 4 if we keep holding down on the up arrow key. So if this is at 2 right here, this will move by 4, so it'll actually be at position 6. Then the next time we hold it down, the velocity is going to be equal to 6 because the last time is 4, so it gets added 2, and so it becomes 6. So since we're at position 6 and we're going to add 6, it's going to be way over here, and it'll be at position 12. So what you can see is the longer you hold it down, the greater the velocity increases. And then that means since we're adding the velocity to the position on each frame, it'll move farther and farther. So it'll accelerate faster and faster, which is what we want to do. But what this means is when you stop holding down the up arrow key, it'll still keep moving at that last velocity. And so you could turn the ship around and then move backwards the other way, so it would slow down and then start moving it in the direction it's facing if you were to like turn it 180 degrees. But what I'm going to do is have it slow down on its own a bit by adding some friction. And I know in space there's no atmosphere, and so you're not going to have friction like that. It's just going to keep on going. But since this is a game, I don't want it to be too difficult to fly around, and I want to still have some drifting around to make it feel space-like, but I also want it to slow down on its own so that it's not too difficult. And what I can do is take the velocity and then divide it by some number. So you could do 2, but what that means is that's quite a bit, so it'll slow down very fast. I want to keep some of the drifting. So what I did when I when I wrote the first game, I tested some numbers, and so I found 1.01 works pretty well. So that in code that'd be divide equals, so because we're dividing itself by 1.01. So now let's go back to CodeHS and modify the MoveShip method to add velocity and rotation. Now we're going to modify the MoveShip method, but before we do that, we're going to have to declare a few more variables, because now instead of moving in an up, down, left, right direction, we're going to have the rotation and the movement in that direction, like I mentioned earlier. So, and we're also going to have velocity. So the first thing I'm going to do is add some velocity variables. So right now we have scroll X and scroll Y. We're going to add scroll XV for X velocity, and that will be initialized to 0. And then we're also going to have scroll YV, and that will be 0. The other thing we'll need to add are two variables for the holding the ship rotation and rotation velocity. So ship rotation will start out as 0, and then we're going to have ship rotation velocity, and that will also be 0. The next thing I'm going to do is add two constants. One will be replaced. This will be ship speed, and that will hold how much we change the ship velocity on each frame when a key is pressed, or the up or down arrow key is pressed. I found that just from the first time I wrote it, 0.7 is a good number for this. And then there's also going to be a ship rotation speed. And then I found 0.01 works well for the rotation speed. So for these sorts of things, I find just you have to do some trial and error and test different numbers until you get the right feel. So for how fast your objects should move around. And so I've done the testing right now, so that's done for you. But of course, you could modify these if you want to have your ship move faster or slower, or maybe you could even have it speed up as the game goes on. So maybe kind of as an incentive to keep playing longer because you want your ship to move faster. So you can do whatever you like there. But if you do change the ship speed, probably you shouldn't have it be like this uppercase format, since that's for constants. Now that we have those variables, I'm back down to the move ship method. We're going to modify that. So instead of declaring move X and move Y, I'm going to just change these to move and rotate, because we're not going to move up, down, left, right. We're going to have that rotation movement. And so when the left arrow keys press, we're going to subtract from rotate, and that'll be the ship rotate speed. And then when the up arrow key is pressed, we're going to subtract from move, and that will be the ship speed. So the reason why we're subtracting is because when you're moving the background instead of the object, when you want to move or make it appear that the object is moving to the right, you'd actually move the background to the left. And so that's why some things may seem a little bit inverted. So now I'm going to go set up the other variables. Okay, so now that we got those set up, we can start modifying the velocities based on how move and rotate have been changed with the keys. So first, let's look at the scroll X velocity and scroll Y velocity. So scroll X velocity, we're going to add, we're going to use the methods that we wrote just now, or a bit ago, the get move X and get move Y. So for scroll X velocity, will be get move X, and the angle we're going to give it is the ship rotation. And then for scroll Y velocity, we have to give it move. Move is going to be the distance. We're going to add to that. And then scroll Y velocity is going to be get move Y. And then also ship rotation and move. The next thing we need to do is rotate the ship. So we're going to add ship rotation gets the ship rotation velocity, and the ship rotation velocity, we're going to add rotate to that. The next thing we're going to need to do is add the friction. So like I said, to make it more controllable, it's going to slow down the velocities. And we can do that by saying scroll. Well, actually, I'm going to do this after we move or add to the scroll X and scroll Y, which these should be scroll X velocity and scroll Y velocity. Next, we're going to take scroll X velocity, and we're going to divide that by 1.01, and then scroll Y velocity and divide that also by 1.01. And these were just the numbers I found through testing. And then on the ship rotation, ship rotation velocity, we can divide that by 1.05. So now what we've got here is we're changing the rotation velocity and then adding that velocity to ship rotation. We're changing the scroll X and scroll Y velocity, and we're calculating how much it needs to move on the X and Y axis using the get move X and get move Y. And those get the ship rotation, which is the same as that variable, and then the move amount from where the keys are pressed. So if we're moving it forwards or backwards based on the up or down arrow keys. And then right here, we're adding the velocity, scroll X velocity to the scroll X, and then the scroll Y velocity to the scroll X to move around in the world. And then we're adding right here the friction. So we're dividing the velocities so that they don't get out of hand. The last thing we're going to do is add the ship to the middle of the screen. There's one thing I want to explain quickly, and that's that when you're dealing with the trig functions, so trigonometry, inside of JavaScript, and also this is the case for many other languages, it's using radians. So this angle right here is in radians, and so what we need to do, our ship rotation is actually in radians too. Since we're not doing any conversion, we're just passing it right into the sine and cosine functions through the get move X and get move Y functions. So what we need to do when we set the rotation of the spaceship, it needs to be in radians. And if radians are a new concept to you, they're just another unit of measuring angle. So I'll show you what that looks like quickly. I know we've been doing a lot of whiteboard explanations, but don't worry, this is the last one for this video. So let's look at degrees, since those are more familiar. And we're going to look at degrees in a circle. So we have this circle. It's going to rotate around this way. And we know right here on the circle would be at 0 degrees. That angle right here would be 90 degrees. Right here would be 180 degrees to 70 degrees, and then back to 360 degrees when we get to here. So with radians, they're just also another way that you can measure this rotation. And there are 2 pi radians in 1 revolution, whereas there's 360 degrees if you're working in degrees. So if you were to look at this measurement in radians, so we're going to go all the way around like this. It starts with 0, so the same right here. But over here is pi. So where you'd have 180 degrees, that would be pi, since there's 2 pi in 1 revolution, and this is halfway around. So over here, this would be pi over 2, since this is halfway between 0 and pi, so pi over 2. And then over here, if we went all the way around, it's 2 pi, so halfway between pi and 2 pi, that'd be 3 pi over 2 radians. So that's what radians look like. And you don't have to worry too much about them because the math, it's all done under the hood. The main thing is that you should be aware of which units you're using. And like I said before, the trig functions use radians. So if we stay consistent and use radians in our program, that'll be easy since we don't have to convert between them. If you did want to convert between, like, say, radians to degrees, since let's say we have x degrees, if we wanted to know how many radians that would be, it'd be 180 over pi, because you can see right here from 0 to pi is 0 to 180. So you see right here is 180, 100, and then right here the equivalent angle would be pi. So this would cancel out the degrees and then multiply by pi to give you the radians. So back to the code editor, we're going to need to add to our init game method. So first let's add the spaceship to the center of the screen. So here it's stored inside the object map, so we can access it with object map.ship. Let's set the position of that. So set actually, let's use our set position centered. So set position centered, and we're going to give it object map.ship as the parameter of what we're saying the position of. And then for the position, get width divided by 2, get height divided by 2. So we're going to put that in the center. And then we need to add the ship to the center, to the canvas. So object map.ship. So that'll put it on the screen on the initialization. And then next we need to rotate the ship. So right here with rotation, we can say object map.ship.set rotation, and then ship rotation. This set rotation by default takes in degrees, but I want to show you something handy. If you look at the full documentation, and we're working with a web image right now, so let's look at the set rotation method on the web image. You can see here that it actually can take in 2 parameters. So it takes in the angle, so by default it's in degrees, and then it also takes in an angle unit. And it says right here whether it's in degrees or radians. And since we're giving it radians, we want to make it indicate that in this parameter. So if you actually look at the code for the set rotation function within the circle class, you can actually see how that works. So right here, internally, the web image uses radians to measure the angle, but I think they want to make it a little bit easier for students using CodeHS. So by default, it'll take in degrees, and then it'll actually just convert those degrees to radians within the function. But if you give it radians, it'll actually just directly assign its rotation to the value you give it. So let's see, right here for angle unit, if you go up to the top, you can see they have a couple of constants. So there's degrees and radians. So if you want it to be in radians, you put in a 1. And if you want degrees, you put in 0. So back over to Meteor Galaxy, we want to give it a 1 since we are using radians for our rotation. Now it's time for the fun part where we get to test the code. And the one thing I noticed that I did incorrectly was on, let's see, the constant for ship rotation speed. I referenced it as ship rotate speed, so I'm gonna change that here, and let's run it. So we got a cool intro, and now we can fly our spaceship around. So the stars are doing the right thing. They're doing the parallax background, and you can fly and rotate, and it'll go in the direction you're pointing, and then it'll also kind of drift around. But then if I'm not pressing anything, so you can see hands off the controls, it'll gradually slow down since we're dividing the velocity. So that makes it a little bit easier to control. But now it doesn't have any meteors or no laser beams or boundary to the world. So those are all things that we're going to add to the future videos. So there's a lot of stuff there. But for now, you can just fly around peacefully and enjoy the view of all the stars. So that's pretty neat. Alright, that brings us to the end of this video. Congratulations on making it through, since this is probably the hardest video in the series, but you learned some of the most important things when it comes to doing movement and velocity and those sorts of things in games. So those techniques will allow you to really take your projects to the next level. But that also means with the hard things out of the way, there are a lot of cool things to come that'll make the game really fun to play, like adding the meteors and the laser beams. So I hope you all come back for those videos, and have a great day. Thank you so much for watching. Goodbye.